Hello everyone, my name is Deepa Banjara and I'm a leader of Robotics project and she's a member, her name is Maya and his name is Zachary. So first of all I would like to share a small story. It's my personal story. So one day I was talking with my younger brother and I told him that I am a member of Robotics project and he sent me a video. That's cool, right? It was a transforming robot. And I said, no, it's not my video. It's not the robot that I worked on. So I sent him a video of my own robot. Yeah, cool, right? And he said, your robot is cool too. So I know what he was not thinking about that as a transformer. So anyways, I know our robot was close to transformer too. So from the video that my brother sent me made me realize that I'm going to utilize the opportunity on getting as much knowledge as possible on robotics and apply it to make a robot which will look like a transformer or some other robot that can be used in day-to-day life. So that's my personal inspiration. So the main goal and objectives of our project is to design and build a competition robot based on the rule provided by 2018-2019 competition, and also to collect more points and to win the games. The main purpose of our robot is to get used to different technique and mechanism which will be utilized to make a robot for the future. So before going any further, I would like to explain what BEX is. The BEX Robotics Design System is a robotic kit intended to introduce students as well as adults to the world of robotics. So as always, BEX organize a seasonal competition every year. So this year, our competition is gonna be a turning point, which will look like this.
Welcome to the world's greatest 2 minutes in robotics, the 2018-2019 game, robotics competition, Turning Point. Turning Point is played on a 12-foot by 12-foot field by two alliances, one red and one blue, made up of two teams each. The object of the game is to score more points than the other alliance, using caps, flags, balls, and platforms. Caps are scored for the alliance whose color is facing up at the end of the match. Caps are 9 inches wide, and robots can possess one cap at a time. Caps scored on the foam tiles are worth 1 point each. Caps scored on posts are worth 2 points each. Flags are scored for the alliance whose color is facing towards the field at the end of the match. Low flags are worth 1 point each. High flags are worth 2 points each and can only be toggled by being hit with balls. Balls are 3 inches in diameter, and robots can possess up to 2 balls at once. The platforms in VRC Turning Point are used for parking. Robots that park on their own alliance platform at the end of the match will receive 3 points. Robots that park on the center platform at the end of the match will receive 6 points, but they'll have to hold their ground because there's not much space up there. The VRC Turning Point field has 8 caps, 6 posts, 9 flags, and 20 balls. There are 2 alliance platforms, 1 per alliance, and 1 center platform. Robots will begin each match with 1 ball as a preload. Each match begins with a 15-second autonomous period, where robots will score on their side of the field without any help from their drivers. The alliance that scores more points in the autonomous period is awarded with 4 bonus points added to the final score at the end of the match. The 1-minute 45-second driver control period begins once the autonomous bonus winner has been determined. At the end of the driver control period, after all objects and robots have come to rest, The match will be scored to determine the winning alliance. Detailed rules and game information for Vex Robotics Competition Turning Point can be found at roboticseducation.org or vexrobotics.com. To register a team, find events near you, or ask a question on the official Q&A forum, be sure to visit robotevents.com. Best of luck on a great 28.
Alright, so our current activities include a ball launching system, which mostly consists of a catapult, and it uses a drivetrain to actually mostly uses a drivetrain to fire the balls mentioned in the challenge. Then there's the rotating and extending claw. Now, this one, the idea is to mount a. Sorry. The idea was to mount a claw to a wrist to allow it to actually toggle caps, and to stack them on the posts. It's going to utilize a rack and pinion to extend and retract. Then there's also a transforming base in which at least one of the robots being used will have legs, which will extend and retract to allow it to climb onto the parking zones. Now, for the ball catapult, for this the catapult covers how we're supposed to toggle the flags. So, as mentioned earlier, it uses a drivetrain as well as a rubber band to fling the ball. So it'll store tension in the rubber band or one of the metal pegs being used for the arms. And when released, it'll allow the launcher to when released, it should allow the it'll allow the
it'll allow the ball to launch to tackle a flag, so the video will look like.
Go. Oh. I'm out of force. Sorry about that. Alright. Now for the extending claw arm. Oh. Well, it's already a short video anyway, so, Alright. So yeah, this is for toggling the lowest flags, as well as picking up, flipping over, and or possibly mounting the caps. So the actual claw part itself is mounted to a wrist, if you will, and there's a servo motor mounted on both the claw and the wrist, allowing it to open and close and rotate respectively. Now it can only turn the wrist can only turn 180 degrees in either or 90 degrees in either direction from a neutral position. But that should be more than enough to flip the caps over. The rack and pinion. Now it's going to utilize, as mentioned earlier, the arm's going to utilize the rack and pinion to extend and retract as needed. Now, frankly, this is still a work in progress, so there might be either a drivetrain installed, or it might be just directly mounted on a motor to raise and lower it as needed. That said, the claw arm may also be needed to load the catapult, and since Now, due to the overall weight of it, due to the overall weight of the claw, it might have to be set. I might have to install either like a counterweight at the back of the arm, or just mount the system near the back of the robot. So this is how a rack and pinion works. You have say one gear controlling a bar of it basically allows for sorry. This for as you can see it sorry. This
Yeah,
right.
it'll use a sliding
Sorry.
system to toggle lowest flag, and it will also allow to put the disc in the hole. Yeah, that's her job.
Alright, sorry.
Into door.
So for the last part, of our design, we thought to bring Deepa's idea, which would be to add like a transformer prototype. So let me refer to my notes. Yeah, so we're gonna build a hidden transformer into the robot that will secure like the bonus points, such as securing the parking space. And the challenge we have is we are limited to use motors, we're limited to use gears, and also we have to keep in mind the weight of the robot because the main objective is speed. And yeah. Did it done?
Yeah.
Okay. On the conclusion. So our approach to design a competitive robot requires us to divide it into subtasks among our team. That way each member can focus on their task, and it will allow for creativity, multidiscipline by like researching, and also communicating with other team members working along the project. So the tasks are open-ended. Like I said, this experience leads to solving skills, critical thinking, and on the basis of the fruitful areas, just to use a fancy word in there, we engage in some engineering tasks, but it's not limited to engineering. It opens up more doors to dive into more technology aspects and learning. The end.